আপডেট করে দিয়েছি তুমি।
Good morning, everyone.
Good morning.
Thank you. So, actually, we are discussing the signal space constellations, and today I will extend the more part because when we will represent or when we will adopt any system, obviously, all kind of representation or all kind of analysis should be completed there. So, to consider that things now, last day we learned that how to develop a space, isn't it? And the name of the process was Gram-Smith orthogonalization, because we know that every basis function, that means which can be treated as the unit vector for the vectorial space or the Euclidean geometry. So that kind of function, what is known as the basis function, every basis function that is orthogonal to each other and normalized to unit energy. So that means when we take dot product in with itself, then it gives us the result 1 within the time duration. And when it takes the dot product with any other basis function except that one, then it leads us the result 0. So that is why they are orthogonal and orthonormal basis function. And there we have learned that how to develop the space, and obviously the input or the basis of the reference of this thing was the set of signals, input signals. So suppose you were given a set of signals or a group of signals. Suppose the group is consisting of 4 number of signals, group is consisting of 5 number of signals. Based on that factor, we can develop the space. And obviously, the limitation is that the maximum dimension of the space that should not exceed the number of signals present in the group or in the constellation. Okay, because if there is any space or if there is any dimension which exceeds the things, that means suppose your dimension becomes 6 of the space, but your constellation that is consisting of 5 number of signals, that cannot happen. Then what is the problem? The problem is there should be some undefined factor or undefined expansion coefficient, because the normal relationship between the state of the signals and the basis function is there is some expansion coefficient. So just like the thing is, if I draw the things, just like the thing is, suppose this is your space and this is your coordinate of the constellation. So obviously these coordinate have some correlation with this one, this coordinate have some correlation with this one, which actually we called as the expansion coefficient. If any dimension of the space is there where there is no correlation, that means if we draw the perpendicular from this particular coordinate to that dimension or to that axis, if that is not valid, then that space is not valid for that particular state of signals. Okay, so always the dimension of the space that is less than maximum is equal to the number of signals present in the constellation or present in the set or the group. So after considering these things, now we will consider that what will be the representation for the channel. Okay, so our title is conversion of continuous AWGN. This AWGN, you know, additive white Gaussian noise, because this is the specification of the channel. That means channel is of very wide bandwidth, that is wide frequency. Additive means the possibilities of mixing, usually we consider in terms of this summer model. So that is why it is additive. And the nature of the all other signals, they follow the Gaussian profile with some particular mean, where what we have considered here zero mean Gaussian profile. So the adjective what we use for the channel for our analysis is always AWGN channel. Okay, so AWGN channel, repetitively you have heard this terminology, I think. Channel into a vector channel. Let us see that how this happens. And for this one, what we will consider, that we will consider a bank of correlator. What you know by correlator? Correlator is actually a group of product integrator block, isn't it? If you can remember your last discussions, then correlator is nothing but a product integrator block. A product block followed by an integrator block where the duration of the integration is just equal to the symbol duration. That means the validity of the symbol, validity of the set. That is the thing. And let me complete it with dt, this one. And what will be the dimension of this one, that actually based on that what is the dimension of the space, because here actually we take the product with the orthonormal basis function. So let us consider a block of this kind. Suppose for the generalizations we are taking, this is up to the n. So phi nt, this every line is identical except the identity of the phi 1, phi 2 up to phi n. Okay. And here usually we feed a common input. So that may be ST, that may be XIT, whatever is the thing. Okay. So usually we feed that common input to the bank of the correlator. So, and from there we get the identification of the things. So here this will be SI1, this will be SI2 up to this will be SIN. If we feed XI, then obviously it will be XI1, XI2, at the last one this will be XIN. Okay. So let us consider a bank of correlator. So this is nothing but a bank of correlator. And what is the reason of these things, that actually we need that what kind of representation we will follow for the channel? Then why we are considering this thing? The reason is that whatever the component we feed into the channel, actually when we feed into the channel, because of the AWGN nature of the channel, it get mixed with the representative function of the Gaussian noise in terms of the addition, and then we get an output function from this one. So just if we model the AWGN channel, then this is the thing. WT is the sample function from the noise group, where WT follows a profile of N0 by 2 input noise power spectral density with 0 min and with Gaussian profile. And suppose this is your deterministic signal component what is coming from the transmitter. So after passing across this one, the identity of SIT, because of the WT, is become something different, and as it is get affected by the sample function of the random variable or the random process or the random function, whatever the terminology you are using, you can use here, the identity of SIT converted into some XT. And usually we can write for this one, the XT is equal to SIT plus WT. And this is a very generalized form of equation what we use for the channel or what we use for the processing of the signals. Last times or prior to last time, several times we have used this configuration. Okay. And here this thing obviously, when we are considering for this one, this is obviously valid. That means this T is valid for 0 is less than equal to T, less than is equal to capital T, which is valid for our passband, any kind of things. And the I is equal to 1, 2, 3 up to M. Okay. So that is the normal thing. Now the idea is that what kind of effect is produced over the channel. To consider that things, as the correlator, which is also known as the analyzer, they can analyze that what are the detailed happenings that happens inside the component or inside the vector quantity. So that is why we are taking a bank of correlator, and from this bank of correlator, out of this one, we are taking an arbitrary line. Suppose that line is, suppose that input line is jth line. Okay, so when we are taking this jth line, so that means suppose here as you have 1 to n, so 1, 2, 3, 4 up to n. Suppose here jth means any line out of 1 to n. So if we take that things, then the outcomes that can be written as in this way, xt, or as xt is equal to this, so let us consider this is xj. Xj, this is equal to integration 0 to t xt phi j t dt. Let us see how this happens. Suppose xt you are giving here and you are taking the second line. So for second line, what is the thing? The thing is xt multiplied by this phi to t, and then it will be integrated over the 0 to t interval, because this entire thing is valid for the symbol duration, otherwise there is no validity. Then your output will come in form of the x2, isn't it? Similarly, when we are considering the jth line, so that means the orthonormal basis function which will be activated there, that will be denoted by phi jt. So here what is the thing? Xt multiplied by phi jt, and as every product is followed by an integrator block, so obviously we have to take the integration over this one. So integration 0 to t xt phi j t dt. This happens if we consider out of 1 to n the jth line. Clear? So xt we can write is equal to like this, and if we write it separately, then this becomes Sij plus Wj, where j is equal to 1, 2, 3 up to n. J is any variable. So that generalization we are showing in terms of j, and for any kind of things that will be the thing. And how it becomes, because you know that when we take xt like this, then instead of xt what you will write is it plus wt, because that is dictated by this relation. Xt is nothing but the deterministic signal component plus the signal component plus the representative function from the noise group. So instead of xt, if I write here is it plus wt, so that means for superposition principle, one integration will come from 0 to t, just this one. Let me, instead of writing this, let us follow like this. This is equal to integration 0 to t. Xt we can write with the help of this one is it plus wt into phi j t into dt. Then just we can write this integration 0 to t is it phi j t into dt. This is one part. Another part is integration 0 to t wt phi j t into dt. Then what happens? Si phi j means Sij, because that is the relation for the expansion coefficient. So that means with this factor, this Si is related to phi j. Similarly for Wt, this will be replaced as Wj, isn't it? So what I have written in terms of the ready-made function, they are matching. Okay. So in this way, we can write this one. So from this one, or from the operations of the correlator, we are very much able to define that the total component or the output is consisting of two terminologies. One is the deterministic function, another is the probabilistic function or the random function, where the Wj is the projection of Wt over the jth orthonormal basis function or over the jth function. So that is the thing. Now to get the clarity that how does it depend on the whole group of the function, for this let us consider another random variable. For this let us consider another random variable, rather random process. Process usually we show with the upper and variable. Okay, so that means whole process is shown in terms of the capital X, and when we take a sample function from that one, then that part is shown with the lowercase of x. Just for the things what you have considered, whole capital W means for the whole group of the random function or the noise group. When we take the sample function, then we take small w. Okay, so that kind of things here we are taking, and let us take the relationship in this way that this x prime t is equal to xt, which is an sample function from the random variable or the kind of things what we are considering, that outcome of the any channel, outcome of the things we are writing in terms of xt and we in terms of these two. So let us consider that xt is equal to j is equal to 1 to n xj phi jt. What does it mean? Let me clear again. Xt, we know xt is a random function, or xt is small xt is a random variable which actually represent the sample function as the outcome of the channel, and that we know that is consisting of, because the channel we are representing in terms of the additive white Gaussian. So that is why we know that xt is consisting of the two components. One is the very deterministic, very well known SI component. Another is the function or the contribution which is coming from the Gaussian profile or coming from the all the rest functions, that is from the noise group or the undesired signal group WT. And when we analyze this xt with respect to some bank of correlator, there we find this is clearly is equal to Sij plus Wj. But till let us search that whether any other residue function or any kind of mixing is there or not. Because here we have considered the additive mixing, and because of the additive mixing, here we are getting the outcome in terms of the sum of two components. So although you're getting the correlator outcome or the product integrator block outcome as a sum of the two very well-known component, one is Sij, another is Wj. Till now, let us have a search that except this, any other component is there or not. And if that is there, then how it is affecting your Sij, or what is its relation with the Sij. In search of that things, what we are considering an another random process x prime t, which is not related to your capital xt, and the representative function or the representative variable with which we will take the processing of the things, that we are writing in terms of small x prime t. Obviously the small x prime t is not a part or not a factor which is coming from the xt. And how we are relating them, we are relating them that this is an another function, this is an another random process which is present in the channel. And how we are relating this is with xt, we are relating this is that this is a separate identity except the xt group. So if it is present, we are searching it is, if it is present, then what will happen? Obviously it will be within this, and how its existence will be checked. If we take the difference from the xt and the sum of all the correlator block, and if it is non-zero, then some residue function is existing, but that is not affecting your system. But if it is equal to 0, then that means that random process or that variable is not existing. So whatever is the thing, whether it is existing or it is not existing, if it does not affect our system, then we can discard it. Okay, so let me search that whether x prime t exists or not. So to do that things, let us substitute the relevant portion for this xt and for this one. So if I substitute, then for xt what we can write? For xt we can write these things, this one, that is SIT plus WT. So let me write that XT is equal to SIT plus WT minus, this is the sum of all the product block or all the outcomes. If we take the sum of all the outcomes from the bank of correlators, then this is this outcome. Okay, so if I write this, then for this one xj and phi j, these things will come up as summation over j is equal to 1 to n. This one, because already we have defined this, so this will come up as Sij plus Wj into phi gt. Okay, so let us write the next line. Wt, they following as usual, and for this one j is equal to 1 to n Sij into phi gt minus j is equal to 1 to 1 Wj into phi gt. This is equal to what? From our definition, this is nothing but the total set of signals. So this can be written as SIT plus WT. This terminology we will write as SIT. This as J is equal to 1 to N WJ phi JT. SI get cancelled out, and we are left with residual function from Wt and outcome of W from the correlator block. And as W is representing the random function, so subtraction of two random function is also a random function, or also the kind of the Gaussian profile or the kind of these things. So this we can represent as an residual random function, as this is related to this x prime t. So let us indicate that residual function, that is gap between Wt and the analysis of W across the jth function, that is in terms of another residual function with W prime t. Okay. So what is our, our conclusion? Our conclusion is this x prime t, existence of x prime t is purely proportional to some residual noise function. It is not related anyhow to the signal detections or the signal component or the kind of things. Okay, so that means we can write, or we can sum up this W prime t is purely residual random function. It never disturbs the signal component. और আমরা যদি লাইনটাকে রিভার্স করে লিখি, রিভার্স করে লিখলে কি লিখতে পারি? xt is equal to summation over j is equal to 1 to n xj phi j t plus x prime t, isn't it? Because the identity of the channel usually we write in terms of xt. So as we have obtained that the difference between these two is related by some residual random function which not at all disturbing your signal component or the coordinate somehow, because wj is that is hampering, but this w prime t is totally uncorrelated function. So that is why the xt, because here the title is conversion of your continuous channel into the vector channel, and the identity what we will write, that we written, that write up will be in terms of the xt, because outcome of channel usually we represent in terms of x. So that is nothing but the correlator outcome plus this x prime t. So if I write it clearly, then this is equal to summation over j is equal to 1 to n xj phi jt. This x prime t is purely is equal to some residual random function. So that is your w prime t, and this relationship what we give, what actually represents the total vector channel. Okay, why it is vector channel? Because you know the thing is very much similar to the Euclidean vectorial space, so that is why it is vector channel. So vector channel xt is represented by this expression, and this is the converted outcomes of the vector channel. Okay, so these are things you are getting there from there. Now the thing is, as because of the presence of the WT, your signal component become deterministic, and instead of SI, just from this relationship, from this one, your SI is a deterministic component. You know that what is your S1, what is your S2, what is your S5. You know all these things. But when it get added with WT, then it become XT. So that xt is not a deterministic component. So as xt is not a deterministic component, so we have to characterize this xt. That means just how we characterize the wt. We characterize the wt with zero mean, profile is Gaussian, with some input noise for, because as it is representing some group of functions, so obviously it should have some input power density. Otherwise, it will not be able to hamper the deterministic signal component. So that things we are showing in terms of your n0 by 2. So like that things, we have to characterize the function of the xt. That means what is the mean value of xt? When SIT is added with WT, we are getting xt. The mean of SIT is obviously the expansion coefficient or that things. That means if we draw the projection from SI up to the orthonormal basis function, what is the remaining? That thing is the mean of SI. Mean of WT is 0. Already we declared or we have started our operation with that assumptions or with that consideration. So that things. So now let us search that what is the mean of xt. That means when a deterministic mean is added with zero mean, what is the mean of that things? When we find the mean, then the variance, because that xt is a random variable. So that means how much is the range of its fluctuation. Variation means the fluctuation, because it is not coincident to a single point or a single value. It has an perturbation or it has a kind of oscillations. So when it has oscillation or it has an uh, oscillatory behavior, then we have to find that what is the variance. That means from what is the range within which it is getting changing or the kind of these things. So that is actually known as the statistical characterizations of the variables. So let us follow that things. So after the obtaining of the identity of the vector channels, now the things what we will follow, that is the statistical. If we are not able to find the characterizations of these things, we will not be able to find the receiver. Okay. So statistical characterization of correlator output or the vector outputs, whatever you can say. Why the correlator output? Because this bank of correlator will help you to get the identity of the things. So when xt is fed, we get that xi1, xi2. That means a set of such n number of variables within this xit. Okay. So let us find that what are the mean of these all these variables. So that is why we have taken the title as statistical characterizations of the correlate. That means we are able to find out the uh, statistical characterizations for every outcomes, for every variable. So for this one, let us start with SI, XI. Okay. So here the thing is you have to know the process very well. So let me clear. Otherwise, you will be mixed up with the notation. Random process, and these are the random variables. When we are taking that capital XT is the random process, its variables will be shown by this. Suppose we are taking an extra random process X prime T, its variable will be represented by this one. If we consider Xj is a random process, then its variable will be written by Xj, like this one. And Wj, it is the it is for wj also. Wj is the random process and its sample function is small wj. Okay, where this is with zero mean, So that means this Wj is makeup of W1, W2 like this, Wj, Wn. Okay, so that is the kind of things. But every this one is by this. Okay, so that is the thing, and they are of zero mean with input noise pause spectral density by n0 by 2. Okay, that is the thing. So now with this, let us find mean mean of xj. Okay, so mean actually we use the sign mean mu xj. So that is equal to expectation of this. Okay, what we are finding? We are finding the correlation output. So for the correlation output means that is valid for every line. So we are taking the jth line, that is why here mu xj, and this is nothing but this one, expectation of this xj. So when we are writing the expectation of this xj, then the detail of xj is how? What? The detail of xj is sij plus capital Wj. This is the thing. Okay. So if we separate out, then the thing is expectation of Sij plus expect, because expectation is nothing but an integration for the overall range over the time duration. So obviously it will, we can write this argument of the integration in terms of the two part. This okay. Expectation of this is what, if we take the integration of this is the mean value. That means mean value of this is what? Already we have considered this is of zero mean. And mean value of this is what? These are deterministic component. So when we take the expectation of this Sij, as Sij is deterministic, very much deterministic component, isn't it? The projection of ith signal component over the jth orthonormal basis function. There is no vague, no random component, nothing is. It's a pure signal component, pure deterministic component, pure defined component. So obviously, whatever the integration we take, always it will be Sij, no changes. So this is equal to nothing but Sij. So, although x is equal to Si plus W, but if we take mean of that things, mean of that is Sij. This is very obvious because suppose this is your signal component, okay, and when it pass across the channel, it is get added by Wt, and because of Wt, this function now becomes, instead of a deterministic function, it becomes now inside a cloud of randomness, isn't it? And the randomness is very much dependent on the variance. That means addition of Wt is how much oscillatory behavior is producing over this deterministic component. And because of that things, when we are writing this outcome as xt is equal to Si plus Wt, the thing becomes a random process, or thing becomes a random variable, isn't it? But the basic of this is whatever the addition, whatever the subtraction that is happening with respect to this Si. So when we are trying to find the mean of x, mean of x is always based on mean of the signal component. Okay. So mean of the signal component is here. That means the purely deterministic component. And when it passed across the channel, then because of the Wt, it is now not a deterministic. It becomes quite random. So that is why a hazy picture is coming there. And our role of the receiver will be remove this haziness and find wherever it is. So if I calculate this mathematically, then also we can see that every haziness or every wandering nature or wandering identity what we are developing, that thing is over this deterministic component. So that means because of the WT, it is now covered with some cloud of haziness. Okay, so that is why mean is this. Now let us find that what is the thing for WJ. So for WJ the thing is WT phi JT. Now let us see variance. Okay. So when SI added with WT, this X is also Gaussian, but its mean is Sij. Now the things what we are trying to find, that is the sigma factor. That means what is the variation. Okay. So variance usually we use the symbol sigma. So sigma of xj square is equal to variance of xj is equal to, we can write, how do we find this? We know what is the mean. So if we take the subtraction of the variable, random variable and the mean, that will give you that how much deviation we are getting because of this wandering nature, isn't it? Because of WT, your SI becomes wandering variable. That means it is giving you some random behavior. But this random behavior is produced over the mean Sij. So how much is the wandering? How much is the variation from its mean value? How do we can find this? If we take the subtraction of this xj and the mean value. So that the things here we are taking expectation over this one. So this is xj minus sij square of this. And how it is, what it is? Xj means your Sij plus Wj minus Sij as a mean. Sij, this and this get cancelled out, and prior to this you can introduce another line for your clarity. Xj minus mu xj, then you write this line. That will help you to find the relation of the variance. So this one, so this means expectation of Wj square. So to find this, that is expectation of Wj square, we have to take Wj into Wj. So Wj is equal to, if we write this is, then this is equal to integration 0 to t Wt phi j t into dt, and another Wj you are writing in this way, integration 0 to t. Obviously one expectation will be outside the whole one, Wu phi j u du, where this. So that means this is representing one Wj, this is representing another Wj. For the generation of the picture, both the t and u, they are time. Both t and u represent time variable. Okay. So this representing one Wj, this representing another Wj. Let us take this one, expectation of integration 0 to t integration 0 to t. This one is Wt Wu phi j t phi j u dt du, isn't it? Just to have rearrange the thing. If we take expectation of this Wt and Wu, this will give you one kind of correlations. And as W is a sample function from random variable, so obviously this will not be autocorrelation. This will be a kind of ensemble average correlation. So whatever the thing we are getting for this one, that things we can write in terms of That means expectation of this we can write in terms of RW TU. Okay, and we are left with this one phi JT phi JU DT DU. Now what we know that set of basis functions, they are orthonormal. Okay, so if they are orthonormal, then for only t is equal to u, you will get the product of phi j and phi ju same. Otherwise, they will lead us 0. Okay, so if t is equal to u, then RWTU is equal to, as you know, this is equal to n0 by 2 delta t minus u. So this means this whole thing is coming as n0 by 2 into 1, and this is also as 1. So sigma xj square, this is equal to nothing but n0 by 2. Look at the things whether this is valid or not. Obviously, this is a very valid answer because you are trying to find out the variance of xj, and variance of xj is produced because of the wt. So what is the variance or what is the input noise spectral density for wt you are taking there? It should be equal to that, because otherwise the other part of x is si has no variance. It is a very deterministic component, but xi is a random variable because of wt. So how much is the variance? The variance should be purely proportional to the input noise power spectral density, what is happening there or what is present there, isn't it? So this is purely is equal to n0 by 2. So these things we have considered for this one. So if we consider the pair of signals or the pair of correlated output, that means we are taking the one output is xj, another output is xk. For that things, if we try to find the covariance, then let us see that what are the outcomes. Covariance between pair of correlated output. That means you are taking two outcomes and trying to set there. So that things we can write as covariance of xj, xk. So what is the thing? As covariance, so covariance of xj will be how much? This is will be expectation of xj minus mu xj, and covariance of this will be xk minus mu of xk, because that is the basic relation of variance. So as it is handled with pair of set or correlated outcome, so that is why we are taking one outcome is xj, another outcome is xk, and when we take the deviation from the mean for this one, take the product and expectation, we will find the covariance. So obviously you are left with expectation of xj, this is equal to what? This is equal to sij, sij. This is equal to what? Sik, this one. So this is expectation of xj minus sij means what? Wj is remaining. Wj, xk minus sik. So what is the remaining? The remaining is wk. Isn't it? So we are taking the expectation of wj and wk. As without going into the detailed calculation, we can see the expectation of this is equal to 0. Because when we write the detail of this one, there will come two basis function. One is phi j, another is phi k. And as j and k are totally different line, so phi j and phi k they will not be equal to 1. If they are not same, because of the orthogonality, the result is 0. So let us do that. This is equal to integration 0 to t. That means expectation of Wj you are writing here. So that is equal to expectation of, for Wj what you can write, Wt phi j into dt, and for Wk what you can write, integration 0 to t W. If you write the time with a different variable, then Wu, this is as the phi Ku into du. So we are taking totally different set. Okay. Integration 0 to t, integration 0 to t, expectation of Wt, Wu, and the remaining part is phi j phi Ku dt du. Okay. So this part will give us how much, integration 0 to t, 0 to t. This will give us delta of t minus u, means n0 by into n0 by 2, like this, phi j t phi ku dt du. As these two are different, so always they will lead us uh, 0. So this means n0 by 2 into 0 is equal to 0, as j is not equal to k. So obviously this will be 0 because the correlated output are not correlated. They are totally uncorrelated. So that the things we are getting. So with respect to all these statistical characterizations, we can define from the above analysis capital X is equal to x1. Okay. But all these random variables, they are independent Gaussian random variables. All these random variables. Because they are independent, that thing is proved from this one. Independent, independent, it is proved from this one. With mean is equal to Sij, and variance, that will be is equal to the variance of the noise function, which is n0 by 2. Okay. So as all of them are statistically independent, so we can write the generation of all these x. That means how this set of random variables are generated. that we can write, or what are the chances that x will be defined by a set of n such variables. All these things we can write in terms of some probability density function, because any random variable, for any random variable, although it is a random variable, but for mathematical analysis we can write the probability density function. That means how much is the probability to arise this kind of functions. So the conditional means when we know the input set is given to you. Suppose you are given with two marbles or five marbles, different color marbles. Then with the set of these five marbles, how much random set you can generate? If I ask you, then you can express it with the help of the conditional probability density function, because the input is given to you. As a input, I have given to you five different color marbles, and with these five different color marbles, you are developing the or you are writing the total set. That means how many different random set you can generate with these five marbles. So when the input condition is given to you, this is known as the conditional probability density function. So the conditional probability density function of x this can be written as like this: if x input is mi, because si is developed from mi. So what are the sets of si? That is very much dependent to mi, is equal to how much, is equal to the big product j is equal to 1 to n f xj mi, where I is equal to 1 to m. Look very carefully. When I have completed all the analysis, then this big X is your total event or the total function, and this function is consisting of this number of variables. How this is possible? When I feed this at the input of your correlator, and what is your correlator? Your correlator is nothing but an analyzer. So this is totally based on how many dimension of the space you are considering. So that means how many orthonormal basis functions you are considering. So when you are feeding any unknown parameter or any variable at the input of the correlator, this correlator will just do this process and will give you the total set or the total picture inside this input. So here your capital X is your event. So if you want to know that what are the component of this random event or this random function, then you have to feed it at the input of the correlator or the bank of the product integrator block. The outcomes you will get these things in terms of the many variables. So they are the input variables for this function. Clear? Am I clear to state this?
Yes,
So this is your total event, and these are the variables or components which are consisting under this event. So when you are taking that your xt is your random process, so under this random process, what is the detail? To get it, you have to feed this xt at the correlator block. Your correlator will give you several such elements. So then they are known as the random variables or the random elements. Now when we are writing here, then this xj, They are the individual correlated outcome. And this capital X is the total event which is consisting of these several such xj's. Is it clear? This capital X is consisting of several such xj's. Just from here it is following. Capital X is equal to, we can write in terms of this column matrix, which is consisting of this n number of variables. And to show the running value of n, we are taking the jth. So j may be 1, j may be 2, j may be 3. So just like this, j is equal to 1 to n. This. So that means conditional probability density function of this big X of the whole is equal to how much is the product of all the random variable, because xj is variable, x is the total. Under x, several such xj's are there. How many are there? That will be indicated by these terminating values. Here, as per our discussion, under the x, n such variables are there. And the probability of this is, that means the chances that we will be with such x is what is equal to the product of that from every mi we are getting, this is the random variable. And just if you write this, then xj, what is this? This is j mi. This is equal to what? This is equal to what we can write in terms of the Gaussian function. So in terms of the Gaussian function, you know the mathematical detail of the Gaussian function is root under pi n0 exponential minus 1 by n naught xj minus sij whole square, like this. Okay, where I is equal to 1, 2, 3 up to n, and j is equal to 1, 2, 3 up to n. So this is the product of all the individuals. Every individual is written by this one. So if you write the total and this bar under mi, this indicates this is conditional probability density function. After the bar, what is given at the input, that means with what reference this x is developing, this is the input condition. So f of x mi is equal to what? Is equal to the product of all these things. So product of all this means, this means pi n0 whole to the power half. If we take the product and this is in the denominator, so this will be n by 2, this one. And for the rest one, exponential minus 1 by n naught, প্রোডাক্ট নিলে কি আসবে, সবগুলো পাওয়ারে অ্যাডিশন হয়ে যাবে। j is equal to 1 to n xj minus sij, this. Okay. So this is the conditional probability density function. And from this it becomes very clear that the random vector x is completely characterized by the xj phi j. Okay, and it never depends on any other residual function or anything else. Although it is clouded when it is passing across the channel, then with respect to mi you are getting this total random variable, total random function, and this random function is totally based on this, because xj minus wsij is what? Wj. So this is totally represented by this function or analysis what you have written here at the time of the first one, this one, wj. Okay, this is not related to this. This is simply is equal to wj. What does wj means? Wj means the projection of w over the j. So that means
it is giving us this clear picture. Actually, if we take j is equal to 1 to n, xj minus sij is nothing but j is equal to 1 to n wj. And wj means projection of wt over jth basis function. So that means that part of wt will affect your signal detection. Actually, the part which is the projected value of this over this. Otherwise, the rest part do not affect your signal detection. This is a very important message. What we obtain from this. Try to understand the things very clearly. Whatever the nature of WT, whether we are taking whatever the frequency band, whatever the kind of oscillation, input power, mean value, irrespective of what we have obtained, that just if we plot the xt and under xt two part is there, si plus w. So within this, just we have to measure the wg. That means when we draw the projection of this over this axis, then it come up as Sij plus Wj. Sij, you know what is. Okay. So somehow if we are able to analyze the Wj, we are able to nullify this also. So that part of noise function will hamper or will affect your detection. That is the projected part, not the whole W. এই কারণেই কি হয়, although the signal component are get cloudy or it get haziness, but till we are able to recover the thing, because only that wj is the affecting part, rest part do not affect your signals. That already we have proved from this conversion of the method. That means this wt, isn't it? If we take the existence of the other random variable, then also we get that the portion of the signals, when we take the subtraction, it is still equal to another residual function. So the whole W will never exploit your entire signal detection. Just the part of the WT over the basis function, that part is the affecting part. And once we are able to measure these things, we are able to nullify this thing also and can detect our signal component from the cloud of haziness or from the total random picture of the XT. Okay. And with this one, just we can write or we can conclude the theory of the irrelevance. So that let me complete it. Based on this, the theory of irrelevance is insofar the signal detection in additive wide Gaussian noise is concerned, only the try to understand the thing, only the projected or the projected value of noise onto the basis function affects the signal statistics. This is a very important message. How much random it is. It will not at all disturb your process except the component of the WJ. Okay. And with this, just I will introduce another more function and we'll conclude today's class, not exceed much more. So based on these things, actually, for the detection of the function, detection of mi, because up to this, what you have written, fx x mi. That means probability of development of x with respect to mi. These things. For detection, we will define another function which is known as likelihood function. It is what? It is the reverse of this one. That means now you are with the x, and with respect to x, what is the probability that you are detecting the fi correctly? This is the outcome of the likelihood function. Clear? For the x, what is the thing? Mi is given. What is the probability that x will be developed over the set of mi? Likelihood function we define for the detection. Detection of what? Detection of signals or symbols. More clearly, they are set of symbols with respect to this. So the thing is, with respect to observable elements. Why they are called observable elements? Because they are observed at the outcome of channel. Why? As they are available at the output of channel. So try to be accommodated with the terms. Observable means outcome of channel. They are always represented as X, because S when get added with W, it becomes X. It is not S then. So likelihood function হচ্ছে x টা দেওয়া আছে with respect to x. What is the probability that you are trying to develop this? So likelihood function কে আমরা লিখি এভাবে L of mi. What is the likelihood to develop mi is equal to this, and the mathematical outcome of this and this, they are identical. So this can be written as x mi. Okay, and instead of normal likelihood function, usually we write log likelihood function. Why the log likelihood function? Because as it is likelihood function, it is conditional probability density, so it is non-negative function. Okay, and if we take the log, then all the front factor or the kind of things, log is a monotonically increasing function, so all the front factor they become irrelevant, because fx mi আর f mix দুটো সেমই ডেসক্রিপশন, সেম ডেসক্রিপশন হলে it can be written in terms of this. So their log likelihood function লিখলে this exponential factor that is totally removed, and this part that is pi n0 whole to the power n by 2, it is not related to statistics of detection, because n0 is input noise per spectral density আর minus n by 2 এটা ওর সঙ্গে ডিটেক্টেড নয়, এটা ফ্রন্ট ফ্যাক্টর হিসেবে আসবে, সবার সামনে আসবে. Just we are left with this one, and as exponential and logarithmic they are cancelled out, we are left with only this one function, that is small mi, this is equal to log of L of mi. ওকে, এটা লিখলে তোমার সামনে কি আসবে? সামনে আসবে minus n by 2 pi n0 into minus 1 by n0 j is equal to 1 to n xj minus sij square is equal to simply this. Okay, because this part is not related to at all any. If we perform the log likelihood function for symbol 1, symbol 2, symbol 3, symbol 4, then we will be associated with 4 different outcomes. Okay, then which symbol is most one? The value which are having the highest log likelihood function, that is the uh, signal component, or that is the symbol component which is transmitted. Are we able to get the justification? Here this is equal to this, so when we perform this, every factor will be associated with minus n by 2 pi n naught. So this is a common factor for all of them, independent of whether we are calculating for symbol 1 or for calculating for symbol 2 or symbol 3 or symbol 4. Suppose quaternary kind of thing is there, so symbol 1 is corresponding to 0 0, symbol 2 is for 0 1, this is for 1 0, this is for 1 1. Suppose these are the 4 symbols, and for these 4 symbols we are calculating the likelihood function with this. So for all of them, n by 2 pi n0 that will be there. So it need not to follow for the maximizations. For the maximizations, what we can do, just we can calculate this one. Okay, we can calculate this one. So Sij, that will be the mean for this, mean for this, mean for this, mean for this, and Xj is the observable. So for every observable, you are taking the difference for the all these mean, and you will be associated with 4 such result. So out of the 4 such result, the result which is having the maximum value, so that is the most probable function, isn't it? Because you tested for 4 things, which one is transmitted, which one is transmitted, for which you will get the maximum likelihood function, maximum likeness for which you are getting, that is the detectable function. So this is a very useful function, log likelihood function, and this is based on the purely the conditional probability density function. Okay, so with the help of this log likelihood function, we are getting a very good directions towards the the receiver or the kind of things. So that will help us a lot for the signal detection. So in the next class, we will see that with the help of the likelihood function, how we are able to detect the set of signals. Okay. So question confusion, I think that many confusions, you are with many confusions, but you are not sharing all those things. What happens as we are towards the termination of the classes, the number of joining student is increasing. It is the reverse factor. Usually students are get lesser, number of joining factor becomes lesser as we are towards the class. Today it is in increasing order.
আজকে বেশি আছে।
বেশি নেই, শুরু থেকে বেশি ছিল না, এখন বেড়ে গেছে।
হ্যাঁ,
তাহলে এটা কি হচ্ছে? এগুলো এগুলো করো না।
ম্যাম অনলাইন
আমি
এক্সাম এবার অনেক আসছে না।
বলো, প্লিজ শেয়ার ইউর ভয়েস, প্লিজ। I think your name is Rohit. You are trying to say something.
না, আসলে এই সেমিস্টারটা অনলাইন হবে তো সেই জন্য মনে হয় কেউ আসছে না।
এটা তো অনলাইন অফলাইনে কি গেল হলো, তোমাকে তো চাকরি পেতে হবে, হয় চাকরি পেতে হবে, নাহলে হায়ার এডুকেশনে যাবে, নাহলে একটা কিছু করবে। এরকম তো নয় যে এরপর আর কিছুই লাগবে না। ওকে, দ্যাট ইজ ইউর ডিসিশন solely. I think you should please turn the pages at least. The things are not so easy that you are hearing and grasping all the things.
ম্যাম খুলে দেখি, একটা পড়তে অনেকক্ষণ লাগে।
তো কি হবে, তুমি এখন পড়বে না তো কি করবে বলো তো, কি যন্ত্রণা, পড়বে না
তাড়াতাড়ি
একটু,
পড়ার চেষ্টা করি একদম
যা,
বুঝতে অনেকক্ষণ লাগে একটা পোর্শন।
সে তো লাগবেই। ইসির একদম কোর, একদম কোর। ধরো তুমি যদি স্পেস ইঞ্জিনিয়ার হিসেবে কাজ করো, তখন তো তুমি একজন টেলিকমিউনিকেশন ইঞ্জিনিয়ার, তো তোমাকে তো জাস্ট কাজ করতে হবে এই ডোমেনটার উপরে। তখন
ম্যাম ডিজিটাল
কতগুলো
কমিউনিকেশনটা বেশ
কনস্টিলেশন,
ভালো টাফ আছে।
টাফ তো হবেই, টাফ তো হবেই। যারা এমই পড়বে কমিউনিকেশনে, তারা দেখবে এটার উপর আরো ডিটেলসে কত পড়ছো, এবং এটার একটা পার্ট তখন রিপিটেটিভ থাকে।
হ্যাঁ মানে
তো
এই
একটু তো
পার্ট
পড়তে
এটা একটু
হবে।
বেশি বেশি পড়তে হয় একটু।
হ্যাঁ, একটু তো রিপিটেটিভ হবে, একটু বেশি পড়তেই হবে। এখন তো তোমরা হায়ার এন্ডে চলে এসছো না, এখন তার এরকম ছোট ছোট জিনিস থাকবে না যে সিম্পল সার্কিটের মধ্যে দিয়ে বুঝে গেলাম, ব্যাস বাকি প্রবলেম গুলো করে দিতে পারবো। এখন তো একটু তো ডেপথের জিনিস থাকবেই, একটু তো দিতে হবে টাইম।
মানে যেমন ম্যাম
যাই হোক,
অ্যানালগটা
আমার
বরং অনেক
রিকোয়েস্ট
সোজা
থাকবে,
ছিল তুলনামূলক।
হ্যাঁ আমার রিকোয়েস্ট থাকবে, তোমরা জিনিসটার মধ্যে একটু পড়াশোনা করো, একটু শেয়ার করো, একটু সলভ করো কি ব্যাপার।
ওকে ম্যাম।
ওকে, তাহলে আমি লিভ করি। থ্যাংক ইউ।
থ্যাংক ইউ ম্যাম।
থ্যাংক ইউ ম্যাম।
থ্যাংক ইউ ম্যাম।
ম্যাম লিভ করে গেছে।